Hello, welcome to the last day of our sequences and series unit. We're going to continue with the binomial formula today. Hopefully you have this written down or have some idea of what this is. We're going to do this one as sort of a review. A plus 3b to the fifth power. If you understand how to do this, pause it and do it on your own. The first thing we're going to have to do is this says we do n choose r. So we start with r equals 0, so 5 choose 0, then we do 5 choose 1, 5 choose 2, all the way up till our r reaches our n. So we'll start with 5 choose 0. We take our first term, a to the fifth power, times our second term, 3b to the 5 minus 0, or 5 minus 5 power, which is 0. Our next term, we do 5 choose 1. Our first term to the fourth power, our second term to the first power. Remember, these two always have to add up to our n. And now I'll say plus 5 choose 2, a to the third, 3b squared, 5 choose 3, a squared, 3b to the third, plus 5 choose 4, a to the first, 3b to the fourth, and then finally 5 choose 5, a to the 0, and 3b to the fifth. Now a lot of you know how to simplify this without writing everything out. I just want to write it all out for you so I'm not skipping any steps. Now 5 choose 0. We can do that a couple ways. First, we can take out our calculator. And on our calculator, we're going to want to hit 5, math, move over to probability, and number 3 is NCR. 5 NCR is 0. That would give us our first term. If I do second enter and just change the last digit to a 1, that would be my 5 choose 1 would be 5. And we could do that for 5 choose 2, 5 choose 3, 5 choose 4, and 5 choose 5. Another way is to use Pascal's triangle, where we're adding the two terms above to get the term below. Since I have 1, 5, this is the fifth row, 10, 10, 5, 1. So this will represent 5 choose 0. 5 will represent 5 choose 1. 10 represents 5 choose 2. This 10 is 5 choose 3, 5 choose 4, and 5 choose 5. So let's try to do this problem. 5 choose 0 is 1. 1 times a to the fifth times anything to the 0 would just be a to the fifth, because 3b to the 0 is 1. Now here we're going to have 5 choose 1, which is 5, times a to the fourth times 3b to the first. So I can multiply 3 times 5 to get 15, and I have a to the fourth b. This next one, 5 choose 2, is 10. 3 squared is 9. 9 times 10 is 90. Then we have a to the third, b squared. This next term, 5 choose 3 is 10. 3 to the third is 27. 27 times 10 is 270. A squared, b to the third. This term, 5 choose 4 is 5. 3 to the fourth is 81. Now I don't know 81 times 5 off the top of my head, so I'll use my calculator. That's 405. A, b to the fourth. 5 choose 5 is 1. A to the 0 is 1. 3 to the fifth, that's 81 times 3. 243. There's no a's, so it's just going to be b to the fifth. So that now I have expanded a plus 3b to the 5th power. Now, you guys can try this one, x plus 2y, x minus 2y to the 15th power. Now we just want the first first 4 terms. I would do 15 choose 0, x to the 15, y to the 0. That's actually, I should write negative 2y to the 0. It doesn't make any difference in this one, but the next term it will. 15 choose 1 times x to the 14, negative 2y to the 1st, plus 15 choose 0, x to the 13, negative 2y squared, plus 15, oh, that's 15 choose 2, I should have said. And then 15 choose 3, x to the 12, negative 2y to the 3rd. All right, now let's try to simplify it. 15 choose 0 is 1. X to the 15th is just x to the 15th times 1. This will be 15. 15 times negative 2 will be negative 30. X to the 14th, y. 15 choose 2. Now I can't do that in my head. So I'm going to do 15 choose 2 to get 105. 105 times 4, because negative 2 squared would be 4, would be 420. X to the 13, y squared. 15 choose 3. Is 455. We're going to multiply that by negative 2 cubed, which would be times negative 8. So this would be, instead of plus, it would be minus 3640. X to the 12th, y to the 3rd. Now, this keeps on going, but our problem just asks for the first 4 terms. All right, now let's expand this. Same principle, now we're just dealing with exponents to an exponent power. So as long as we know our rules, everything's fine. We're going to do, from the previous problem is 1, 5, 10, 10, 5, 1 for our coefficients. So let's just put those in there. 1, a to the 3rd to the 5th, b squared. Plus 5, a to the 3rd to the 4th, b squared. That should be a 0 to the 1st power. Plus the next term would be 10, a to the 3rd to the 3rd power, b squared to the 2nd power. Plus another 10, a to the 3rd to the 2nd power, b squared to the 3rd power. Plus 5/8 cubed to the 1st power times b squared to the 4th. And then finally 1 times a cubed to the 0 times b squared to the 5th. All right. So now we need to know our exponent rules. 1 is just going to be 1, so we don't need that. A to the 3rd to the 5th, we multiply those to get 15. B squared to the 0s, same as b to the 0, which is just 1. Here, the 5 doesn't multiply by anything, but a to the 3rd to the 4th is a to the 12th times b squared. Plus, here we have 10, a to the 3 times 3, which is 9th, b squared to the 2nd power is b to the 4th. Now, the next one has a coefficient of 10, a to the 6th, b to the 6th also. This next term would be 5a to the 3rd, b to the 8th. And then finally, 1 times 1 times e to the 10th. Now let's look at these coefficients. These coefficients now don't add up to 5. See, this is 15, 14, 13, 12, 11, 10. So it looks like there's a pattern. It's going down by 1, but so there's a pattern, but it's not what we had before. All right, try this one on your own. It would be 1x to the 4th to the 3rd power plus 3x to the 4th squared plus 3x to the 4th to the 1st power times negative y to the 3rd squared. And then finally plus 1 x to the 4th to the 0 times negative y to the 3rd to the 3rd. All right, so when we multiply this all out, this would be 1 times 1, and this would be x to the 12th. This next one will be a negative times a 3, so that would be negative 3. X will be 4 to the 2nd power, which is 8. 3 to the 1st will be 3. Plus this negative squared would make that positive, so it would stay a 3. X to the 4th. Y to the 4th. Now finally, 1 times 1 times negative 1, and then y to the 9th. Now let's look at this pattern. This goes 12, 11, 8, 9. Makes me think that maybe I did something wrong. And I did, because this should be a 3. My writing's just bad. And now I can see that this should be a 6. So 12, 11, 10, 9. All right, that looks a little bit better. All right, now in this one, let's just try to find the r to the 7th term. We don't want to spend the time doing out every single one. But we do know that if r to the 7th, s will be to the 16 minus 7, which will be 9. Now we have to look for the term, so that would be 16 choose 7. Or we could have done 16 choose 9, it's the same number, and I'll show you that here. Let's do math. Oh, I should put 16 first. 16 choose 7. And now if I did 16 choose 9, it would give me the same value. So 11,440 r to the 7th, s to the 9th. That's the r to the 7th term. Now find a to the 6th. Well, if a is to the 6th power, b has to be to the 17th, and we can do 23 choose either of those numbers. So I'll just do second enter, turn this to a 6, and turn these to a 23. So 100,947, a to the 6th, b to the 17th. Now do this to the y to the 4th term. So y to the 4th, that's going to tell us that x has to be to the 2nd power. And now we have to look for a coefficient. So our coefficient is a little bit trickier. So let's rewrite this, because we know 2x has to be squared, and 3y is going to go to the 4th power. And now it's going to be 6 choose 2 out in front. So let's do 6 choose 2. So this is 15. 2 squared is going to be 4. X squared will just be x squared. 3 to the 4th is 81. Y to the 4th. Now we have to multiply all those together. So we have 15 times 4 times 81. 4,860. X squared, y to the 4th. Now you try this one on your own. Find the x to the 12th term. Now x to the 12th, I guess this one is a little bit different because we have x to the 3rd now and negative y to the 4th. Now what do we need for this to be x to the 12th? Well, that needs to be a 4. And if that's a 4, this one has to be a 2. So this is going to be 6 choose 4, which is the same thing as 6 choose 2, which is 15. And now I have x to the 12th. This would be 16 y squared. So I have to multiply 15 times 16 to get 240 x to the 12th y squared. Now this gets a little tricky because the 9th term. So the 9th term, if I have 25 choose, that's not a C, 25 choose 0, that's the first term. 25 choose 1, that's the second term. 25 choose 2, that's the third term. So if I want to find the 9th term, the 9th term will be at 25 choose 8, because this number is always 1 less than the term number. So if I have 25 choose 8, that means my x value will be to the 8th power, and my y value will be to the 17th. So now I just have to do 25 choose 8, 1,081,575, x to the 8th, y to the 17th. There we go. Try this one to the 4th term. So the 4th term would be 7 choose 3. So our r would have to be to the 3rd power. 3y would be to the 4th power. So 35 r cubed times 81 y to the 4th. So now I just multiply 35 times 81. 2,835 r to the 3rd, y to the 4th. All right. Now in this situation, let's find the a to the 8th term. We did one similar to this. Maybe you could do this one on your own. I have a squared, b to the 5th. Now what power does this have to be to make it a to the 8th? The answer is 4. If that's 4, this one has to be 6. So I have a 10 choose 4 there. So 10 choose, try that again. 10 choose 4. 210, a to the 8th, b to the 30th. So you can see we have a to the 8th, so that's the term we're looking for. You can try this one on your own. We have x to the 4th, negative y to the 3rd. The y to the 15th term would need a 5 there, because multiplying that will give us that value. So if that's 5, 8 minus 5 will give us 3. So 8 choose 3 will give us the coefficient. 56, x to the 12th, y to the 15th, and that negative to the 5th would make it negative out in front. All right, here's the homework. Good luck.